Okay, so now that we know how to find arc length, let's actually apply it to some specific circles. So part A, what is the length of arc AD? Express the answer in terms of pi. So when they say this, that means no decimals, and we leave pi in our final answer. It's considered a more exact answer because we don't have to do any rounding. So that's often a preferred way to leave answers. It is the better answer. It's a little tricky because sometimes the decimal answer gives us a better sense of what that measure is. But if we need an exact answer, they'll tell us to leave it in terms of pi. All right, so what is the length of arc AD? Well, a couple things. We use two letters to name the arc, so we're talking a minor arc. If we look at our picture, if I go from A all the way around to D this way, that's more than 180 degrees. That's more than half the circle. It's bigger than a semicircle. That would be a major arc. If they wanted that, they would have included a third letter. They could have said A, B, D or arc A, C, D. But if all I said was arc AD, that means we're going from A and we're finding the quickest path to D. So that is arc AD. All right, so how do we find the length, that is arc length of AD? So first thing, we need to find the arc measure of AD. Remember, the arc measure is equal to the central angle. So if I want to know what this arc measure is, let's figure out what the central angle is. Well, we've got all these other angles going around, which is basically the rest of it. So you can look at that in terms of relating the central angles to the arc. So arc CD is 104 degrees, arc BC is 43 degrees, and arc BA is 73 degrees. So the arc we need is 360, the full circle, minus those measures. So we're going to subtract out the 73, the 43, and the 104. And so the measure of arc AD will be equal to 140 degrees. Remember, an arc measure is measured in degrees, whatever your central angle is measured in. All right, step 2. Now let's find the arc length. We have two formulas for this. Our circle, we can see all of those angles and arcs are measured in degrees. So let's use the formula that uses degrees. So that formula from our previous example is S arc length equals N is the measure of the arc over 360 degrees times 2 pi r. All right, so let's fill in some things. N is the measure of the arc, that's that 140. So 140 over 360 times 2 pi r. And because I know that I have to do some reducing here, I'm going to put the 2 pi times our radius of 4 up top all over 1. I can reduce anything from the numerators with anything in the denominators. You can do that with multiplication of fractions. I'm going to do a quick divide by 10. Divide by 10, those zeros are gone. I know that 4 will fit into 36, so I'm going to divide 4 by 4, I get 1. I divide 36 by 4 and we get 9. Do 14 and 2 have any common factors with 9? And if we think through that, we'll say, well, no, they don't. So we can go ahead and put our final answer together. Arc length is equal to, we have a 14 times a 2 pi left over, which is 28 pi over, in our denominator, we have a 9 times a 1. So 28 pi over 9, that's an acceptable answer. You might see 28 ninths pi as another way to write it. Honestly, both of these are okay. But I just want you to recognize 28 pi over 9 is the same thing as 28 ninths pi. Okay, so a couple more. This next circle, what is the length of arc JK? So JK, again, just our arc is named with 2 letters, so we find from J the quickest pathway to K, so it is a minor arc. Express your answer in terms of pi. So again, we're going to not divide out and get a decimal. So follow the same steps we did above. First step is to find the arc measure of JK. And if we look at the picture, well, they told us the central angle is 3/4 pi radians, so the arc measure will be 3/4 pi. Okay, step 2. Now that we have that, we can find the arc length. And then this is going to be in radians, or using our formula that used radians. So our formula from our previous video, arc length is equal to theta, the measure of the arc, times your radius. Well, remember, if your central angle is 3/4 pi, your arc is 3/4 pi, so we're just going to plug in a 3/4 pi times our radius. Radius is 5. I'm going to put that as 5/1. Now what I'm looking for, this pi is just going to kind of hang out there. That'll come in our final answer. But if you look at your numerators, we have a 3 and a 5 over a 4 and a 1. Are there any common factors we could divide those by? In this case, there's not, so we'll just multiply going straight across the top. 3 times 5 is 15. 4 times 1 is 4, and then that pi just comes along. So the arc length is 15/4 pi. All right, last one. We're going to use that same picture. What is the length of arc HK? So let's look at the picture. I'm actually going to erase some of what we have. Arc HK is, if it's just 2 letters, it's the quickest pathway. That's a minor arc. So how do we figure out what this angle is right here, the central angle? Well, we know this one is 3/4 pi. We know this one is 1/3 pi. So all we do is we take the total in radians. Remember, 1 full time around the circle is 2 pi. That's the same as 360 degrees. Well, actually, hold on. Let's do our steps. So first, we're going to find the arc measure for HK. So to do that, we're going to take the full circle, 2 pi. Let's subtract out. In this case, to me, it makes more sense to subtract out the 1/3 pi plus the 3/4 pi angles. So if we focus on this, I can see fractions. It's always good to talk about fractions. I know we can type this into our calculator, but if we have 1/3 pi and 3/4 pi, we have a 1/3 and a 3/4. Why don't we get that up to 12s? Let's talk in terms of 12s. So 1/3 is the same thing as 4/12 pi. All I did was I multiplied the numerator and denominator by 4. We're going to add to that. Now I want to get this in terms of 12. So if I multiply these by 3, that will get me 9/12 pi. Now that they're both in 12ths, we can add them together. So 4/12 pi plus 9/12 pi is 13/12 pi. So I'm just going to carry this down. 2 pi minus 13/12 pi. So again, I know you could do 2 minus 13/12 to get that. But again, it's always good to think about fractions. If I can write this 2 pi in terms of 12, remember that's a 2/1. I can just multiply those by 12 and I get 24/12. That's the same thing as 2 pi minus 13/12 pi. And now 24 minus 13 gives us 11/12 pi. Okay, so I know I'm going into a lot of detail here, but again, the more we talk about some of this math, hopefully the easier it seems, right? So step 2, let's find the arc length. we are talking radians, so we get to use our arc length formula in radians. S equals theta times your radius. Well, we just figured out theta is our arc measure. So that's 11/12 pi times the radius for this same circle is 5. So I'm going to put that as 5/1. Then I'm going to look to see I have 11 and a 5 in a numerator, 12 and 1 in denominator. Do 11 and a 5 have any common factors with 12 and 1? Any reducing we could do there? And there's not anything. So we'll just multiply straight across and get 55 over 12 times 1 is 12. And then the pi just carries along. And there's our arc length in radians, 55/12 pi.